Okay.
All right, so we're joined from Houston, Texas, by petroleum engineer, doubles HBCU SWAC graduate, and friend of the class, repeat guest Alaric Jones. Thank you so much for joining us. We're recording this for all of our computer science engineering students in Madison County Schools, our YouTube channel. And I've got a room full here with me at Velma Jackson High School. And last time, you taught me something because I did not realize how much that we have, that we use, that we are in every day, that chemical engineers touch. It,
Oh
it
yeah.
really is every single thing on the planet that some sort of chemical engineering has to play a part in. Um, and we'll talk about what you do. In our last class, we had a scientist that actually made the chemicals before it gets to you. So that was a great segue. So
Mhm.
before we get into all of that, talk a little bit about, you're from Alexandria, Louisiana. Then you went to Southern University in Baton Rouge, and then Prairie View A&M out there in Texas. Um, two HBCUs, two great HBCUs, members of the SWAC, and that led you to your career. So before we get into what it is you do, talk a little bit about your college journey.
So my college journey goes back maybe about 50, 60 years ago. So I'm a third generation Southern University Jaguar. My mom and dad met on campus right in front of the cafeteria. And then I was created and here I go. And before that, my grandmother, she was a Southern University Jaguar too, graduated in 1968. So it was destined for me to attend Southern University. Um, it wasn't too many choices I had coming out of high school. I had always been to Bayou Classic, the rivalry against Southern and Grambling in the Superdome. I had been to a few Jackson State and Southern games, and that's a big rivalry too. So it was always ingrained in me to attend Southern University.
That's awesome. Now, and then from there, you got your degree, and then you went to Prairie View for grad school in the Houston area. So, talk a little bit about your choice, not only to do another HBCU, but what drove you to Prairie View.
I graduated in chemistry from Southern, and so just doing research, I was like, man, I want to make some more money than what a regular chemist does. So my sophomore year at Southern, I did an internship at Shell Oil Company in
Okay.
Houston, and I interned with a lot of Prairie View engineers at the time, and so they spoke highly of the school and the engineering program, and so I had a choice out of Prairie View, and then I applied to USC in LA, and then North Carolina A&T in Greensboro. So my philosophy was, man, how about I just go to another HBCU in the Houston area, which is the uh the US oil capital. So
Absolutely.
where all the oil and gas companies are, I figured it would be an easier way for me to get a job once I graduated. And so I chose Prairie View and matriculated through there and found me a successful job after that.
That's awesome. Now you are a chemical engineer by title, and you are
Mhm.
in the petroleum industry. Now, for maybe the kids that don't really understand, petroleum and gas is not just stuff you put in your cars. There is so many things that use petroleum and gas, from manufacturing to airplanes, ships. I mean, obviously the vehicles, but and that's just off the top of my head. So, uh, what is it that you do in this industry to make sure all of this stuff is flowing correctly and being refined correctly, safely, for the health of everyone, from the people that are actually doing the refining to the end user?
So specifically, like you said, oil and gas is not just what you put in your car. So you start off with crude.
Yeah,
Crude is basically fossil fuels that you get from underneath the ocean and on land underneath ground. So we have to drill um, with miles and miles of pipe through the ocean, and they extract the crude from the ground and basically send it to land, and it takes it to a refinery or a plant, which is where I work at, and we can you say it's computer science in the room, right?
yeah,
Okay. So I don't want to get into too much detail, but so that crude, think of that crude as Kool-Aid. Think of the Kool-Aid pack as something you may need daily. Think of the sugar as something you need. Think of the water as something you need. So if we think we drill our Kool-Aid out the ground and we have to separate those different components in order to use for different things. So we have different gasolines we put in our car. We have different gasoline we put in our airplanes. We have different gasoline we put in our trains and boats. And then we have other products we make with petroleum products like your tires you put on your car, um, all kind of things. Different things you use in the classroom. Probably the plastic pens you are probably using right now. Those are made from petroleum products. So
Wow.
basically, our job is to take that stuff and separate that into different components using different chemical reactions and chemical pieces of equipment. If you think about if you're driving past a plant, you see those tall towers. Those are called distillation columns, and these different components are separated by boiling point. So if you think about if you have a pot of water, everybody knows the boiling point of water is 100 degrees, and so essentially getting that water into its gaseous phase is called separation. So that's what we do with the different components that are within crude. Uh, it's a little more detailed than that, but high level that's what it is. So um, but me specifically, I take care of what comes in the plant and I take care of what comes out. So I get to interface with different cross-functional groups. So I'm an engineer. I get to talk to finance people, I get to talk to computer science people, and I get to talk to business people because at the end of the day, some people when you have jobs like in retail stores, we have to keep track of how much we have to keep an inventory of what we have in our facility. So I get to see how much money everything is worth and all kinds of stuff. So I do a little bit of science and a little bit of business aspect of things on my job.
Yeah, and that's a great point because when in any type of manufacturing, obviously you can make a great product, but if you can't sell it, nobody's going to make any money. Because
Correct.
yeah, if engineers are going to make money in any type of manufacturing, what they're manufacturing has to be bought. So
Hmm.
that's a great point. So obviously we have a lot of big manufacturing plants here in Mississippi, with Nissan and Levi's and U.S. Foods and some of these other ones, and have a need for petroleum engineers. But like you said, if they can't deal with the business people and let them know about the product, they can't sell it. And that is
Right.
such an even if you are a talented engineer, you have to have that skill of sales and people skills in order to be successful in any type of business.
Right. And we call those soft skills.
Yeah.
Soft skills, you have to know how to talk to people. You have to know how to present what you are your findings or your learnings and communicate those. And believe it or not, a lot of smart people they're book smart, but not necessarily the most communicative people. They don't have those soft skills, so it's important to learn how to communicate. Right now, while you're in school, especially with your teacher, with your other classmates, they'll definitely help you in the long run.
Yeah, and along those same lines, one thing that I always say is people in any industry, especially if you're in engineering or something, with that much money and safety at stake, you
Mhm.
have to be able to explain things to people like they've never heard of it before. So you have to be the expert. You have to be the one that knows everything about what's going on. And one thing I can speak for all the teachers that are going to see this later. One thing that we struggle with is that these kids, we give them an assignment, they don't get it right the first time. Oh, this is too hard, I quit. So
Right.
how often do engineers of any sort, especially in the chemical realm, how often do they actually get something right the first time?
Right the first time. Not often. It's usually a series of steps, and
Yeah,
you kind of run into brick walls. I
yeah,
wouldn't necessarily say get it wrong, but you do run into brick walls where you can't advance in the process. So if I'm trying to figure out what's 1 plus 1 plus 5, I know I have one, but I need to figure out what's that next number to get me to pass that equal sign. Well, I can't find that next number because this temperature doesn't look right, this pressure doesn't look right, this flow of this certain chemical does not look right. So we kind of run into brick walls like that. But the education we have, the chemical formulas we learn in schools, we're able to apply those and hopefully figure out that missing answer in a timely fashion. So
yeah. And along the same lines, something that has to be rewarding is that in chemical engineering, unlike other areas of engineering, you get to deal on the scientific side, but you really have a lot of responsibility because not only are you making products that have to sell and there's money at stake, just one of the more dangerous parts of engineering because if something goes wrong in the manufacturing process, not to scare people, but somebody could be killed if there is if you put forth a reaction that does not work. Obviously, I'm not a chemistry expert, but I do know that the reactions have to be tested before they're used and the product separated.
Yeah, that's correct. We do pilot plants, which are small scale plants of what you see in person, maybe the size of maybe a 5 or 6 desks in the classroom, and they do small scale testing just to make sure that safe and do what we want them to do. Because at the end of the day, safety is always priority. Like you said, not to scare people, but they do have accidents in the plant environment. Whether there's some hydrochloric acid that ends up squirting on your face or your hands, and it ends up burning your hands, or some people may get their arm locked up in a valve or something just because they're doing unsafe things. So we always try to put safety first and try to mitigate things where we can prevent ourselves from getting in those situations. So
Absolutely, and I think especially any type of factory setting, that's so important. Now, obviously, in your case, you're in an industry that is going to keep growing. But from what you've seen, as far as chemical engineers, where is the need for this career going? Because obviously, manufacturing is not going anywhere.
no.
It's going to get more and more technologically advanced, but a lot of the laborer jobs are being done away with. Things are getting more automated, so people really need to look into these engineering programs because that's where the future of manufacturing is going. Or I could be wrong. What do you think about that?
So oil and gas is starting to go into a different direction. So my company currently is called Pemex, but we used to be Shell. Shell sold us to the Mexican government basically because Shell is trying to get away from oil and gas because it is dangerous to our environment at certain levels. So you see a lot of companies trying to shift to different biofuels, electric type cars, and stuff that's safe for the environment. So and a lot of these different sources of fuel, they need computer softwares to build programs to model to see how they work, because at the end of the day we're not going to be in the field all the time. We're not going to be physically putting our hands on these valves, so they need computer programs to predict what's going to happen. And people are smart enough to predict what's going to happen using chemical formulas, chemical equations, and all you got to do is put it into a program, and it'll spit out what it's supposed to be. So I think computer science and computer engineers are a very huge asset. I deal with them every day because I use a computer program right now that predicts what should be flowing, what temperatures and pressures should we have in our systems, and sometimes it breaks down. It doesn't read what it's supposed to read, so I have to work with those guys and gals to figure out what's wrong with the computer program.
Yeah, and before I get to my questions from the students, that's what I wanted to ask next. Is that how many different computer programs have you had to learn? Because a lot of these kids right now they're all watching you on a MacBook, so they're all used to the iOS. But a lot, most engineering jobs are not going to be using the iOS system. There are several types of operating systems and software systems that you have to learn that may change after you graduate and start the job. So, how important is that, and what all of you had to learn in that aspect?
I don't know what's on my resume, but probably 20 to 30 different programs. A
Wow.
lot of those I learned in school, of course. Microsoft Word, Microsoft Office, Microsoft PowerPoint, Photoshop to make my presentations look good. And then there's Visio. Visio, for you computer science people, that's what you use to build code or create whatever you're trying to create. So like in school, we take a class with Visio, and we have to build an ATM. We got to tell the ATM, this is how much money we're putting in the ATM, and the ATM needs to know how to calculate or do the math to figure out how much you have left over in the ATM. So Visio is something like that you would use to create different programs that we use in a work environment. It's a plethora of different things and softwares that we use, and people specialize in building these programs. So it's definitely a lucrative uh, career choice to get in. Not only that, the computer scientists and computer engineers, they are offering those guys right now a lot of money right now, coming fresh out of school, like in a like 150,000 plus range per year. So if you are interested in computer science,
Yeah,
it's definitely
either
lucrative.
looking for military folks as well, folks straight right out of these military jobs after 4 years in the Air Force, getting
Hmm.
those technology certs. Like you said, they're getting 150, 175,000 at 20, 22, 23 years old.
Right, right.
All right, but I do have some questions from the students. This first one is Justin Clerk. He's a senior, and he asked, as a chemical engineer, what would you say is the most important piece of equipment you use?
Most important piece is probably so all of the equipments, they work together. Um and so we have different pieces of equipment that do different things. We have heat exchangers, because sometimes you have to heat up your chemical to a certain temperature so that in order for it to do a reaction. So that's a important piece of equipment. Like I stated earlier, we have distillation columns, which are about 200 feet high, depending on the component. And like I said, distillation columns are they separate chemicals. And a cool thing about distillation columns, the height of the distillation column is dependent on how hard it is to separate the component. So
Wow.
if you have a component that needs to be, you have two different components, their boiling points could be real close together, and so they become harder to separate. So the taller the column is, the higher the boiling point and the closer the boiling point. So that the height of the column gives it time to actually separate as it goes throughout the column.
Man,
I can show you better on paper and stuff like that, but high
that's
level, that's what
incredible.
it is. So we also have big old tanks full of chemicals. I don't know if y'all pass on the highway, but they're big and white, maybe 100 foot tall, 100 foot wide, but they store chemicals in there. That's our storage tank. That's our pots, our Tupperware where we put our food in right there. So and that's crazy. So financially and economically, we meet weekly to see what's the most profitable um type of gasoline we should be making that week,
Yeah.
and we put a recipe in, and we call it our recipe for the week, and that tells us what type of gasoline is gonna make us the most money and what we should be making that week. So it's
That's
a
awesome.
lot of different pieces of equipment that are important. All of them are important because they do different things. So
That's awesome. I never knew any of that. This is Brenda Escudero. She's a senior, and she asked, "What is the part of your job you enjoy the most?"
um Brenda, good question. The part I enjoy the most right now is I get to interface with a lot of different cross-functional groups, and cross-functional groups means different departments. So I work in process engineering, and so like I said earlier, I keep inventory. So with me keeping inventory means I know how much chemicals in each tank. So when I talk to finance or the business people, and I tell them how much is in each tank, then they're gonna tell me, okay, well, this tank is worth $24 million. This tank is worth $50 million, and this tank is worth $10 million. So I get to see money and dollar signs. It's not for me, but I get to see it, and it's kind of like a proud moment. Like you get to handle
Oh yeah,
uh, 500 million billion dollars worth of chemicals, at one time. So
pretty
it's
awesome.
good to get to have that experience and have that science and technical background too.
Yeah, and
So
also to put, you talk about soft skills, putting things like that on your resume. That's something specific you can say. Handled $500 million worth of chemicals, XYZ. So having
yep,
that exact concrete number is so huge. And I know the kids get sick of me saying that, but that can, anything you can measure and put on paper is what looks better. So
Right.
that's got
Right.
to be really cool. This is Layla Young. She's our Miss Velma Jackson senior. And she asked, was there anything else you wanted to be before you became a chemical engineer?
Uh, I wanted to be a professional baseball player, but that didn't work out. Um, I also wanted to be like a lawyer. I kind of had a good itch that I wanted to be a lawyer, but I decided not to take that route. I wanted to make the most money as early as possible as I could, so I went chemical engineer. But actually now I'm thinking about going to law school as a chemical engineer, um, and to practice patent law, possibly. Patent law is where you have people who are scientists who come up with inventions,
Yep.
and so with these inventions, they have to be approved, and there has to be an application done. So the only type of person who can practice this type of law is a person with a science degree, a
Wow.
chemistry, a biology, a engineering, a computer science, or whatever.
Wow.
And so they need a lot of these type of people um, in the patent law industry. So if you are considering, doing any kind of sciences coming out of college, law school is a good route to go. Just because you're in science doesn't mean you can't practice law. They're all different phases of law.
Man,
So,
that's a whole different conversation for another day, but I agree 100%. They literally
oh
need
yeah,
attorneys for every field on this planet with all kind of backgrounds, from farmers to scientists to fishermen, you name it. They need attorneys and everything. So that is a great opportunity. If that works out for you, that's going to be incredible.
oh yeah, most definitely. Especially out here in the Houston area, it's a lot of different patent law firms out there.
Absolutely. That's awesome. I just got one more from the students. This is Korea Baker. She's a junior. And she asked, when you come across a task you think is too difficult, how do you overcome it?
I got to reach out for help. I basically write on a big cardboard sign. I write HELP, and I just I raise it up in my office and I ask for help. But no, I reach out to my coworkers. I have a good support staff for my coworkers and my supervisor. A lot of sometimes there are more experienced people than you, and like I said, you got to have soft skills. You can't be afraid to reach out to other people and ask questions. When you do ask questions, you tend to learn more. You might learn more than you thought you were about to learn. And a lot of times, it's not a single person effort. It could be a group effort, and I'm lucky to work with a good amount of people at my job that are willing to lend a helping hand when there is a question at hand. So, just today alone, I probably reached out for help like 3 to 4 times today. So, um, asking for help is not uncommon. It happens quite often. So, if you do need help, always ask it. So.
Yeah, and then I always say, I guarantee you there's somebody else that has the same question. So
Oh yeah.
it's gonna be beneficial to the whole team for that to happen. Now we're almost out of time, and we thank you so much for joining us. Every time you talk to us, it's amazing how much I learn because you
Oh
just
yeah.
taught me some stuff I had no idea about, and I know everyone will appreciate it. But before we go, you're from Alexandria, Louisiana, which is not that far away. You grew up as a black kid in the South, but you have 2 degrees from 2 great universities, and you're in a really fast growing field. So why
Mhm.
should these young people that are watching now, watching later, consider getting into chemical engineering or any type of engineering? Because, like you said, there's a need for them across all fields.
It's a very lucrative business. Excuse me. And engineering just doesn't come across chemical. There's electrical, there's civil, there's mechanical, there's structural, there's computer. There's all kind of different things you can do in this type of field, and the work is very rewarding. It's an industry where you can see your product. You can see somebody using your product or see something you did to help contribute to a product. So, like myself, I see people put gas in their car. It's something I help refine or help make, and I put work and effort into it. And so, you always got to stay focused, be on time, make sure you have good resume, make sure you know those soft skills are there when you do finally come out and try to get a job. So, um, I think this is probably one of the easiest jobs industries to get in because there's so many opportunities out there. And once you get to college, make sure you intern. I did 4 internships while I was in college. My first one was with Shell. My second one was with GE Aviation in Cincinnati, and then I interned with Monsanto, which is now Bayer in St. Louis.
Wow.
And they make dicamba, which is in Roundup, fertilizers and stuff like that. So, and yeah, man, that's gonna build your resume. And when an employee goes in to interview you, they're gonna be like, "Wow, look at all these different opportunities. This person's able to do this, and that." So, yeah, just stay with a good resume and intern. That's my advice.
Yeah, and it's amazing what the networking can do, especially in a field like engineering, when you're doing the internships. All of our guests in other class say the same thing. So, um, good, and that's some really cool internships. Wow.
Yeah,
I've never been to Cincinnati, so that's really cool. So again, Alaric Jones, chemical engineer, Houston, Texas, double SWAC grad. We thank you so much for joining us, even though you rocking the SU stuff. But as always, we are SWAC.
that's it.
All right, talk to you soon, my
Appreciate you.
friend.
All right.
See ya.